Hey everybody, welcome to session 11 of The Joy of Coding. We are, I feel like we're in the home stretch. I was sort of looking at this week, next week, and the week after that. So not a bad thing, of course, is going by. Um, and well, we're really, tonight we start learning about the final topic in the course, which is Android development. What we're going to do tonight is get our environment set up to build an Android application. This is a sanity check that we do, well before the end of the course. Even though I realize that, most of you probably won't be writing the code for a couple of weeks. I want to make sure everybody has the ability to do so, and because there's a new tool set with Android, and I want to make sure that everybody can get it working in their development environments because you can't work on the PSU machines for Android. But so we'll be talking about that tonight, and then in the second part of class, we're going to be doing an operating theater exercise for mob programming. So on Wednesday is our first mob programming activity. This is an in-person activity, so I look forward to seeing everybody in class. We've got this awesome classroom that is just ideal for it. We've got 4 projectors around the room. We'll have 4 mobs, and which I think will work with the number of people in this class. There's something like 30 people total, so we'll have decent-sized mobs. And yeah, that's this week. And then really for the rest of the course, it's Android and mobbing because the final exam is coming up in just a few weeks. Before I dive into Android, though, does anybody have questions? Any questions for the Prime Minister? For me, what can I tell you? Let's see here. Project 3 is due on Wednesday. I'm seeing lots of good discussions about it on the Slack. But is there anything else you'd like me to know, or anything else that I can tell you about Project 3? Oh, yeah. The pretty is in the eye of the beholder. Ultimately, what I'm looking for, and what I've instructed the graders to look for, is there evidence that you have formatted your strings, so not just like a 2-string of it or whatever, right? So you've done formatting, that you've attempted to arrange the text nicely, with the duration of the appointment, and that's really, and that they're sorted. I think the sorting is a big thing. I realize I didn't make that like super explicit in the assignment, but the intent is that the pretty output is sorted, but the appointments in the pretty output are sorted. Yeah. Oh, good question. If I implement a comparator, should I implement equals? Yeah, it's best practice, but it's not necessary because if you override equals, then you should override hash code. But here again, that's sort of a should. You're not going to be using these objects as keys and maps or anything like that. So yeah, can if you want, but yeah, yeah. And at that point, it's like okay. I mean, so that's a good practice. It's not something though that I don't believe it'll impact the behavior of the program. Yeah, good questions. Anything else before we dive into Android? Okay, let's do it then. Okay, so what I want to do in the first part of class is I want to show you how to download, install, configure a tool called Android Studio, which is basically a version of IntelliJ that's been customized to build Android applications. Um, I like Android Studio because it's very familiar to IntelliJ users, and so you've been seeing me, and you have been using IntelliJ in this course. So I'm going to walk you through that process tonight. Hey, feel free to follow along if you want, or take some time tomorrow or maybe later this week after we've got Project 3 done to go through and on your own to make sure that you can follow these steps that they're successful to you. If you encounter some problem, please let me know as soon as possible so that we can figure out how to get Android working in your environment. It's been a while. It's been several years since I've had any students whose development environments couldn't run Android. But here again, I've had a couple students in distant past that couldn't, and so we had to like really figure out what to do to get them to be successful in this last part of the course. Let's see here. I really won't be going into too many details about Android, but I encourage you to watch the Android fundamentals screencast to sort of just get your bearings for what you're going to see tonight. Let's see here. I'm going to go to Project 5. I'm not going to talk about Project 5 now, but this has a couple of links in here that are important. Mainly this developer.android.com. And so this is where you start. So nice. Oh, here we go. Download Android Studio. That's what we want to do. So I'm going to go through a bunch of steps tonight. There are a couple of things I've got to do on my machine because it is super old. But hopefully, it's things I think will be okay for yours. Okay, so you want to download the latest version of Android Studio. It's called Narwhal, and so we'll do that. Now, I've read over these license agreements plenty of times, and so I will agree to them quickly. I have an Intel chip. I said my Mac is old. And then I'll download. So this is the installer for Android Studio. And again, Android Studio is a... Oh, is it really downloading that slowly? Oh, did I delete the one I did this morning? Oh, well. We'll have to wait. There's going to be a lot of stalling for time tonight while we wait for various things to happen. Wow. Let's tell this story. So, like, one of the first times that I did this, this was back probably like, I don't know, 2017 or something like that. And we were in a classroom, actually in the, what's it called, Neuberger back then. It's now the Massey Center or whatever it is, right? And so I had like probably 30 students in the classroom, like, okay, let's everybody download Android Studio, and like everything ground to a halt. It was pretty funny. One person actually like went out to the coffee shop across the street and downloaded it and came back before everybody else was done. It was kind of funny. Anyway, Android Studio is this customized version of IntelliJ, which has all sorts of integrated tools for running your Android application. The idea here is that they want to make it very, very easy for people to get started with Android, for people to have to go back and forth between developing the visual side of the code for Android applications, and then also the logic side, the implementation, the Java code that runs your application. What we'll see here is that after installing Android Studio, we'll go through several steps. We'll first create first what we'll do is we'll download and install what's called the Android SDK, which is a software development kit for Android. It's got the tools that you'll learn about in the lecture, basically the things that compile Android applications and put everything together. And there's all sorts of like tooling and things like that are available, all integrated into Android Studio. Really awesome. And then, so we'll download that, and then we will we'll create a project, and then we'll create a project, which will be, the code that eventually you'll implement your Android app in. And here I am opening now. I'm going to install it on my machine, drag it into applications, extracts it into applications slowly. How big is that? Yeah, 3 gigabytes. Okay, not so small. And also, what you're able to do in Android Studio is run the Android emulator. So Android applications, you develop the application, but ultimately you want to run it on some device. And, there are hundreds, maybe thousands at this point, different kinds of Android devices, everything from, a phone to a tablet to watches to television sets. And so then when you when you develop your Android app, you want to exercise it on the various devices that you're going to support it on. And so Android Studio makes it really easy to run emulators that emulate different kinds of devices. So we're going to see all that stuff tonight. So we download Android Studio, and let's open it up. Okay, yes, I work for the internet and I want to run it. Oops. So let's bring this to the front. There's the Narwhal logo. Okay. So this is a little strange. It didn't used to behave like this. You basically get this empty screen when you start, and it's got some weird PSN file. I have no idea what that is. But down here, so I mean, it's in some safety mode or something like that. Oh, the file is open in light edit mode. A simple text editor with basic code navigation and folding for a full set of IDE features. Open the file in a project. Well, I'm going to say access full IDE here. And it's going to ask me to create a new project, and I want to do that. Now, then it says, wait a second, okay, I want to create an Android project, but you don't have the tools installed. I can't create it yet. I'm like, great, that's fine. Open up the SDK manager. Okay. And so then, this is saying, hey, you can download various versions of the Android SDK tools. And I had to figure this out today. You click on Edit here, which is different. And now then it goes into the wizard to download the SDK components. And it's going to download Android 16. It's going to put it in my home directory in a library Android SDK directory. All the defaults work for me. They'll probably work for you too. And it tells you that, okay, yeah, it's going to download 603 megabytes of SDK components. Great. I'll click Next. And it's giving me a little, thing of here's what's going to download, here's how much it's going to be, or how much space it's going to take. That's fine. 1 million licenses to accept. Please read them over and make sure that you agree with all of them. And then it goes and does it. This will take a little while as it goes and downloads all the components, but it gives you an appreciation for a couple of things. Well, first of all, just the amount of stuff in the Android SDK, all of the tools. It's got a bunch of Java code. I guess it's either. Yeah, I think that might have been either sample code or just source code for the Android SDK itself, so that you can dive into it. And then also, it gives you an appreciation for the kind of stuff that Android Studio does for you. The first couple of times I taught Android Studio didn't have all this nice integration, and we just spent a lot of time downloading the right zip file and then zipping it here, and it didn't have great support for it. It's so much better now, it's it puts everything in the right place and makes it really easy to manage. What it's downloading right now is an emulator, or actually the kind of emulator framework that's used with Android. And again, these emulators are key to being able to exercise your apps on various various devices. The whole idea is that the device manufacturers provide software emulators for their devices so that you can work with them. Okay, great. So it's done all this stuff. Okay, so now it's got an Android SDK, and it's giving me the option to download other ones. I think Android 16 is okay. And now I'm happy with this. Okay. So now I'm back here. I've got the SDK installed. Now I'm going to create a new project. Okay, so there are a whole bunch of different templates for projects. You can create them for phone. They have wearable OS projects. If you want to create an Android app for a TV, you can, or for a car. We're going to keep it simple in this class. We're going to do phones, and we're going to choose the empty views activity, and I'll show you why we do that in a bit. Okay, so we choose this one. The name of our application is going to be Appointment Book. The package name is going to be your package, so edu, pdx, cs, joy. Mine's going to be Whitlock. The save location, we want to put this project in the same GitHub repository as the rest of your code. Now, when you got started with the other projects, you ran a script on the PSU machine. We're not doing that here. We are working with Android Studio to do that. So I need to go find the location of my code checkout. It's right here. PWD to get the whole thing. So here is where my code is. I'm going to put that here. And it's saying that's already existing. That's fine. I'm going to call it aptbook-android. And actually, it's important that you call it aptbook-android because that's what the submit script knows what to do. This next option is the language for the project. So Android was originally developed using the Java programming language. Java at the time was the most popular programming language. Tens of thousands of people all over the world knew how to develop in it. The Android developers were like, great, uh, let's use that language. And it actually worked really well because Android has a VM model, has an intermediate bytecode model, we'll say that much. Intermediate bytecode model, just like Java does. So it made a lot of sense. And then Oracle's lawyers got involved because people were making money off of Android and blah, 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 blah. So the Android community said, we got to hedge our bets. In addition to, we'll do Java, but we'll invent a new language called Kotlin, and we'll use that instead. Kotlin's very nice, and you'll see tons and tons of examples out there in Kotlin. If you're doing serious Android development, I encourage you to check out the language. I'm not going to make you learn a new language with 3 weeks left in the class, so we're going to choose Java for our for the programming language for this project. The minimum SDK is going to be, let me just make sure, I want to make sure, I believe it's 35 is what I recommend. Oops. Let's go back to the assignment. Big again. Yeah, API 35. So we're going to choose, excuse me, API 35. Great. And our build configuration language will be Groovy DSL, not Kotlin DSL. And we'll talk about what Groovy is in a little bit. So, again, create a new project called Appointment Book. The package name will be the name of your package. Put it inside your code checkout, or a checkout of your GitHub repository. Make it in Java, minimum SDK of 35, and use the Groovy DSL. Let's create that. Okay. So it goes off, and it generates a new project. It's basically like an IntelliJ project. Oh, did that not take? Yeah, I don't like this. Oh, there it is. Okay, great. Oh, it's asking me to add stuff to Git. Yes, please. Add all that stuff to Git. Add even more stuff to Git. And yeah, I want to add to Git. That's why I added it. Wow, it was asking me a lot of times. I was complaining about the version of Git. That may or may not be a problem. Okay, so now this is Android Studio, and as you can see, it's IntelliJ, right? It's IntelliJ with some new stuff, and we'll talk about some of the new stuff. Right now, it is sitting there. Let's see here. It is it's doing a whole bunch of stuff with this project. So it's gone and it's create a bunch of source code. I'm not going to look at the source code. We're going to save that for next week to really dive into that and what it's all about. But it's if you look at it, it looks pretty familiar. It's got like source directories. And there's main and there's tests. Something called Android test. And sure enough, it's got source main Java and then directories for your package, and then it's got some Java code. And it's got a bunch of XML files for your application, a bunch of configuration. Again, not a discussion for tonight, but something that we'll definitely dive into in the coming in the next week or so. Okay, it's making some progress. It's starting to identify some stuff, and again, it's doing things. It's indexing files. It doesn't surprise me. So Android Studio, the first time you run it, it's gonna do a whole bunch of setup to make sure that everything's running. Now, actually, it looks like it's doing pretty well. It says setting up run configurations. Okay, that's nice, and it looks like it's indexing some stuff. So I'll let it go here for another moment. So I have my Android application, and I've got the source code. So it basically creates this empty app for me. And now I need to be able to run it. So let's see here. If I go to over here, running device manager. So Android Studio lets you manage the virtual devices. Well, actually, both virtual and physical. You can plug an Android device into your machine, or you can pair it with your or you can connect to it over Wi-Fi or something like that. Android device, and you can develop an application here and then deploy it to the device to test it out. That's neat. We're not going to be doing that. We're going to be using emulators instead. But if you are, if you own an Android device and you want to play with it, I've had students do that in the past. It works fine. What I'm going to do here is I'm going to add a new device. And it's telling me create a virtual device or remote device. I'm going to create a virtual device. And then it creates a new wizard for adding a device. We want, let's see here, Pixel, I usually use a pretty old Pixel by now, Pixel 5, yeah. We're going to get a Pixel 5, and we're going to choose that. So this is oh, it's giving me this unknown error. I'll give this a try. Okay, we're going to call this Pixel 5 API 35. Oh, this is using 36. Use 35? Yeah, use 35. And it tells you things about, oh, here's how big the phone is, here's what its dimensions are, here's how many pixels it is, tells you about what's supported, all this good kind of stuff. And you can also configure other things about it. It's actually like it's like you have all the stuff that's on the phone. So you can do that. Oh, and what is it saying? Do I probably need to download this SDK or something? I do need to download the SDK. Sorry, it did 36 out of the box. I want 35. You might need to do the same thing. So while that's downloading, again, what we're doing here is we're creating a virtual device that I can run here on my laptop. That then, as I develop my Android application, I can deploy, for lack of a better word, I can install the app on the virtual device, and I can interact with it on the virtual device. Yeah. Sure. Yep. Add device, add virtual device. Choose a Pixel 5. And then the API is 35 vanilla ice cream. And you probably need to download the system image. Yep. Let's see here. It is now installing things slowly. But again, it's really easy. It's all integrated into Android Studio. Anybody else following along? Okay, yeah, awesome, sweet. Okay. And my understanding is that the software that's in the emulator is actually the same thing that gets put on the phone in the factory, right? You're dealing with exactly the same bits, and so then again, it's in the device manufacturer's best interest to make these software versions of the devices available for developers to work with. Otherwise, you're not going to have as a device manufacturer, you're not going to have a community of people that will make sure that it works on your device. There we go. Okay, now I've got that. Sure, do I need this thing? Yeah, we'll find out. Okay, so now we'll finish this. So creating AVD, that's the Android virtual device. Now I'm pretty sure that if I start this, it's going to fall over on its face with an incomprehensible error because my machine's too old. Yep, unknown error. Okay, so now this is where we pause the nice demo and then watch Dave patch up the super old machine. This is not hopefully steps that you do not have to follow yourself, but I think the thing that I want to make you aware is that sometimes your machine may not work as expected, and this is why we are validating things here in class. I basically have an older version of the emulator that I have to use that works with this old operating system, this old hardware. But it usually works. Not slow sometimes, but oops. Question came in, and a question here in the room. Wait a second. What was the recommended SDK version again? 35. And do you have a question? Yeah. Oh yeah, yeah. Appointment book. Actually, here I have like all this right here. I can put that in the sorry in Slack. Use this information for creating your Android projects. Of course, adjust your package name and location name appropriately. Oh yeah, that could be API 35 instead. Over 35. Oops, I can't edit that. No, that's a display name. It's a good question. Oh, the fact that there's a space in appointment book, will it matter? No, this is just a display name that you'll see in places that doesn't actually correspond to a file name or anything like that. What was I? I was doing all those commands. I was VIing down here. Let me change this to 32.1.14. Not 35, but 32. 32. 5. 14. 32. Oops, 32.1.14. I think that's right. Okay, now let's see if I can start the emulator as I expect from the command line. And the first time you run the emulator, it takes a long time. You just initialize everything and just boot it up and everything. So something to look by. No, that looks okay. Android is a complex piece of software. It has a lot of logging output, and so then, honestly, I don't know if any of these things are problematic or not. Hopefully, they're not. Okay, so here it is. It's starting the emulator, and now it's booting up the device, which presumably is taking a while. There we go. Now the device is turning on. And this is actually a Pixel 5, right? I mean, this is like, you're running it here in this software emulation. And so it's booting up, it's initializing itself. It comes pre-installed with some apps. We can see those once everything gets loaded. But again, this is a really cool thing about Android. The fact that there is this huge library of device emulators that's available for you to develop on. Here again, the fact that it's got all these errors, is that a bad thing? I don't really know. I found that you can be patient with these things, especially the first time. Same if you've been able to install an emulator and run it? Cool. Oh, you know, interesting. Well, I was supposed to do that. Maybe I'll open up Chrome instead. Maybe slow. Huh, it's got these. So now I'm wondering, like, should I quit it and run it again and see if that makes a difference? It took you a little time. Okay, yeah, yeah. I don't know, my patience is wearing thin, so I'm going to quit out of the emulator and start it again and see if it helps. Otherwise, I might need to blow away things and start over again. I'm not sure. I think I followed all the steps too. Try it again. Yep, something's happening. Got a little play button. Wow. Okay, there it is. Right, nothing like going to turn it off and turn it back on again. And poof, you've got a phone, and so you can interact it with the mouse, and just like you would, your finger, your tap display, or your tap on the display, and so you can launch Google Chrome. That comes pre-installed here, and it starts up Chrome. And again, because it's an emulator and because my machine's old, it's pretty slow. Hopefully you all have a slightly better experience with that. And again, the first time you launch Chrome, it's initializing some things, so it's thinking about it itself. There we go. I'm going to use it without an account. But here again, you could like log into your emulator, just like you could any other device if you wanted to do that. Thank you for enhancing my ad privacy. And now you've got your Chrome on your phone, and you can click and drag to do things. You can interact with. Uh, oh, looks like something's crashing, which maybe isn't terribly surprising. I went to K2 News. Okay, well that crashed. Let's not mess with it. Luckily, you won't be using Chrome for this class. I'm going to close the emulator here, and I'm going to quit the emulator. And let's go back to Android Studio now that we got the emulator running. And by the way, the things that we did for like the last 5 minutes here, this was just all what I had to do to get it running. I had to play all that hopscotch with the files. Now that I got it running from the command line, I'm going to try running it again from Android. Seems to be a lot happier now. Oh look, start up the emulator, nice and fast. And so right here inside your IDE, you've got your phone emulator. And now that I've got an emulator running, what I can do is I can build my app and install it on the phone. And the way you do that is they just click the go button, right? The run button, just like you would, run a unit test or run a Java program. And so now this is going to build the the appointment book application that we had Android Studio built for us. Now it's got to compile all the stuff. It's got to build and assemble the application. But it'll do things like compile your Java code for you. It'll look at all your layouts, and we'll talk all about that in the future next time in terms of getting everything looking good and looking the way you want it anyway. And you can check out. And I guess this is a good time for me to talk about Gradle. So um, I think I've mentioned Gradle once or twice in the class. So we've all been using Maven. We learned about Maven. Maven is a build tool for Java applications, and Gradle is recognized as the successor to Maven. And as you may recall me saying, Gradle takes a very different philosophy when it comes to a build system. So Maven is all about providing a standard build system that covers 85, 90% of the Java applications you want to build. But if you want to get that last 10%, it's really hard to do it. Maybe you basically got to write your own custom plugins sometimes, or you end up having to just devolve into shell commands and stuff. It's not terribly nice for that. Gradle said, hey, we're going to provide you with a programming language for doing builds. Here you go. And Gradle is expressed in a language called Groovy, which is a language derived from Java and removes a lot of the syntactic requirements that Java has, and so you can be very expressive in what your code does. Gradle leverages Groovy primarily for configuration, and luckily there's only one change you'll have to make to a Gradle configuration file, and we'll talk about that next week or the week after. But you can use then Gradle to build the Android app, and that's what we're doing here. We are Gradle is putting the app together, it's doing all these things. We saw it was successful now, and now it's launching. So it finally built and assembled the application, and now it's installing the app on the device. And poof, there it is. And it says "Hello World," which you probably can't see that very well if you're here in the classroom. So what we can do is we can then pop this out. We can pop it out here. Is that how you? That's not what I wanted. I believe it's this one. Layout inspection. How do you pop this thing out? Maybe it's this right here. Oh yeah, now we can look at it in its own window. This is how I prefer to do it. It's just bigger. You can see it. It says "Hello World" there in the middle. Not tonight, but when we get back to this code, I guess next Monday, we'll see how all this is done, how you develop this. But the most important thing is that you can verify that you can get this far, so that you can install Android Studio, so you can install the Android SDK, so you can build a project, and you can install an emulator, run the emulator, and then install the app on it. And so if you see "Hello World," then good, you're ready to develop Android. This is IntelliJ. I can easily find the code I need to commit, and I can say commit it. So added Android code for the appointment book Android project. It's analyzing a lot of code apparently. Okay, that's nice. That's a bit more. Okay. Meanwhile, I'm going to dock the device again, and I'm going to stop the device with the device manager. That's going to be taking a while. Oof. This code analysis is something wrong there. Interesting. Turn off all that stuff. Huh, that's interesting. Stop. I can. Good. Okay, now we're going to commit and push and not do any analysis. Good. Oh, interesting. Why can't I push it? Wait, empty repository. That's weird. What happened there? Huh, okay. So it couldn't, for some reason, okay, Git, yeah, maybe you didn't like that old version of Git I had or something. But yeah, it's in the history. Okay, should still be up there. Okay. So anyway, so that's what I wanted to show here at the beginning of class. I wanted to show how to get started with Android. And again, I encourage you sometime this week. Maybe hey, if project 3 is well squared away, maybe do it later tonight or tomorrow. But definitely finish off project 3 before investing too much time in Android. But don't wait to check out Android to make sure that it works on your environment. So anything else you'd like to know about Android development right now? Not hearing anything, I'm going to quit Android Studio to save some resources on my machine. And I am going to open up. Now we'll start talking about mob programming. Okay, let's zoom in a little bit here. Say fit. There we go. That's nice. Okay. So, we've done some pair programming in this course. It was a couple weeks ago. You might have forgotten about it. I don't know. So, in pair programming, you have two people working together to solve a problem. And as I talk about in the mob programming video, after a while, people figured out that there's a real benefit of having lots of people, an entire team, working on the code at the same time. You get all the brilliant minds working on it, and you have lots of people that can provide input into the code and then also consume what is being coded. And so what you end up with is much more resilient teams. You don't have to worry about people going on vacation. You don't have to worry about certain parts of the system only being known by a couple of people. Everybody knows it, and because the work is so visible, it's very easy to provide feedback to adjust as things go. So, here in the second part of the course, we'll be learning about mob programming. We'll be experiencing mob programming, and starting with tonight. So then, just as a little preview, after I talk some more about mobbing and ensembling, I'm going to ask for volunteers here from the classroom to come up and join a mob here at the front of the room, and we'll do a simple tennis kata. Yeah. Oh yeah, I put it actually. Yeah, it's on. Actually, if you look in Slack, there was a message I posted this morning, super early, and I made a reply to that one. Yep. Yep. No problem. No, thanks for asking. So if you go back to the katas project, let's see here. I added a tennis directory, and inside tennis, there's a pom.xml. And if you're interested in mobbing with me tonight, please put your name in one of the mobber slots. And I'm hoping to get 6 people. And so we've got 6 chairs up here to mob. But first, let's talk about mobbing. So the motto, the catchphrase, I don't know, it's pretty long for a motto. The motto of mob programming is that it brings all the brilliant minds working together on the same thing at the same time in the same space at the same computer. And this is really the ethic that people bring to mob programming. It's like you've got a bunch of people that are working together to solve a problem, and people work together not by divvying up the work and handing it off to people coming back and then integrating it later. It's like no, you all work together at the same time. And what it leverages is the voices on the team. It allows everybody to have a contribution to the solution. But just like with pair programming, uh, there are some simple rules and some roles that help ensure that mobbing um, gets off to a good start and stays effective over the long run. So the roles in mobbing, the first two should seem familiar to you. There's a driver. So in the mob, one person is the designated driver. Mobbing describes this person as the intelligent input device. So this is the person, just like in pairing. Their hands are on the keyboard. They are doing thinking, but they are the ones who are writing the code. And an effective driver, you know, it will take input from the navigator and from the rest of the mob to decide what to write. And so then the driver will say things like, "Well, what should I write next?" Or, "Hey, we want to accomplish this. What's a good test for doing that?" And that's a nice prompt back to the navigator, who is the person that takes the ideas from the mob to then provide the appropriate intent to the driver. Um, in mobbing, really everybody except the driver can be a navigator, and so we talked about the primary navigator, that was the designated navigator. They are the person that ultimately is who the driver listens to. The driver can't listen to like seven other people, right? And so then the driver, the whole idea is that they take their cue from the driver takes their cue from the designated navigator. But because there's a mob, because there's multiple people, the navigator role is more than it is in pairing. Where in pairing, the navigator is just talking to the driver, so really the only person you need to worry about or think about is the driver. But in mobbing, the navigator also has a responsibility to the rest of the mob. They're more of a facilitator. So they are asking questions of the mob to get ideas. They are listening to multiple ideas and then sort of deciding and guiding, okay, well, let's try this next. And so then they will instruct the driver that way. So there's the driver, there's a designated navigator, and there's everybody else that are just generically referred to as mobbers, right? So these are the other people in the mob. Their hands aren't on the keyboard. They aren't the one. Well, their hands on the keyboard aren't on the keyboard writing code, but they might be doing other things, right? They might be researching something. Maybe might be figuring out, hey, what is it going to take to get to the next step? Oh, do we need to learn more about this API? Do we need to, think more about the algorithm? And they can be, reading, they can be researching, and they can be documenting, they can be capturing things. And this is another really cool thing about mobbing is that it encourages the creation of design artifacts, of decision logs, to really help everybody understand how we got here, what is the route that we took, and what are some of the decisions that we made along the way. So there are some roles in mobbing that we'll have an opportunity to experience tonight. There are also a couple of high-level concepts that I want to call out, and more detail about this is in the mobbing part of that teaming lecture. If you haven't watched already, I really encourage that you do. It'll help you mob better on Wednesday. But some things to keep in mind. When you're the designated navigator, you want to speak at the highest level of abstraction the driver is familiar with. And we saw some of this in pairing too, how important it was that especially when you've got a knowledge mismatch or a knowledge gap between the driver and the navigator in pairing, that the navigator speak at the appropriate level. So hey, listen, if someone is brand new to the IDE or brand new to the language, they gotta be pretty low level. They gotta be like, hey, click here and select this menu item. Or okay, use the keyword, use the keyword new, or use the keyword. Here's how you do a for loop, right? Type thing. As opposed to the navigation for someone who is more experienced, who is more familiar, you just say, okay, yeah, rename this method, and you use IntelliJ to rename this method, or oh, hey, iterate over the items in that array, right? Just speaking at a higher level of abstraction and making sure that it's appropriate for the driver. You don't want to be too low because that'll be boring if not, and you risk being condescending. But you also don't want to be too high level because they'll be lost and not know what to do. The lecture goes into this a lot more, but there are three core values of mob programming, and that's kindness, consideration, and respect. When you've got this many people working together, you really got to think about group dynamics. This is a bad thing. It's a good thing, right? You understand, hey, how can we work most effectively together? And what the mobbers have come up with is that they it's like no, that we value being kind to one another, right? It's being understanding, and sometimes and actually that speaks that ties in nicely with that first thing to remember. It's like yeah, speaking the right abstraction for someone. So, hey, if someone's new, yep, go a little bit lower. If someone's more experienced, go a bit higher, and try to find where the happy medium is because that can change over time as people learn more or as the problem changes. And same thing with consideration and respect. We're dealing with people here, so let's be nice to them. Mobbing, when you're in the mob, it's not about sitting back and silently watching, even if you're learning a lot, right? You want to participate. And so then it's the job of everybody, but especially the designated navigator, to look for people that are maybe quiet, more reserved, or maybe don't have the same privilege or power in the mob to bring them into the conversation. Oftentimes, these are the people that are have a completely different perspective on the problem, on its solution, and everybody benefits from hearing what they have to say. And if you go through the lecture, you'll see that there are these more advanced roles that have been defined in mobbing, things like an automationist or a traffic cop or an anthropologist. Those are kind of like more advanced things. So for the mobbing that you'll be doing in this course, whether it's tonight or Wednesday or the Wednesday after that, hey, sticking to driver, navigator, designated navigator, and mobber, that's great. That's fine. That'll be plenty. But I do encourage you to learn about some of the more advanced roles because maybe it'll be appropriate to say, oh yeah, you know what, we should probably write that down, or hey, that code's a little smelly right there. Let's go investigate that. So I just wanted to give this quick overview, maybe a review for those of you who watched the lecture about mob programming. There is a lot of resources out there. I've linked to them here. I like this stuff. This is to me this is still pretty bleeding edge, and it's something that I think well I hope that you'll appreciate, if not enjoy, doing as part of this course. Anything interesting about mobbing that you'd like to talk about? So, I want to talk about the kata that we'll be doing tonight. So we'll be working in the operating theater, meaning that we'll have some people up here, and then there'll be some people in the classroom watching, and of course everybody on Zoom will be watching also. And what we'll be implementing is a kata that scores a game of tennis. I hope people are familiar enough with tennis. The scoring is kind of unique. So you have two players that are playing against each other, and every time they score, a player scores a point. Um, the overall score goes from this kind of interesting gradation, right? It starts with love, and it goes to 15, then 30, then 40, and then the rules kick in. So if you have 40 points, and you win the points, so you've got 40 points and you score one more time, then you win the game. However, there's some other things there. Oh, I saw someone ask a question in chat. What's tennis? Thanks, Denny. Good. Kids today. Look it up on the TikTok. Anyway. Exactly? Yeah, right. um, so once you get to 40, these rules, if both players have 40, then you get into a special situation, right? So if both players have 40, then it's called your induce. That is your score. And so then there's a whole notion of like which player has the advantage. And so it's like, okay, if you win a point, if you're induced and you win a point, then that player is an advantage. If that player then wins again, then he wins the game. Otherwise, if the player without the advantage wins the score, scores, then okay, they're back at deuce again, right? So I think you've all seen this, right? You sort of get to 40-40, and then you're a deuce, and then it's like you got to win two more. There's lots more details here, but hopefully we're familiar enough with this problem that we can break ground on it. Yeah, here's another way to describe it, which might be more helpful when it comes to implementing it, and we will ignore the solutions that are out there. Um, Although maybe we'll need them if we need some help. So that is the kata. Anything people want to know about the game of tennis? Any questions before we start? Okay, excellent. So then, we'll do an operating theater modeling activity. And this will probably take the rest of class. We're going to take a break at the end, and then we'll come back and we'll do the ensemble programming. Let's see here. I'll be the initial navigator, but then we'll figure out who goes next. We'll probably just go down the line or something like that. And we will we'll first do a I don't know, like a 5-minute design session to sort of figure out, hey, do we all understand the problem? And then we'll do a series of pomodoros. We'll develop for 8 minutes, and then we'll do a 2-minute reflection, like we do with pairing, but you'll find the dynamics very different in Maven. And we'll be on the lookout for anything that we want to do differently as after that. And then we'll rotate. So the person who's currently the navigator will go be a mobber, and then the person who's driver becomes the next designated navigator. And then we'll find the next volunteer to be the new driver. Let's just do, I don't want to get code with me set up. Let's just do push-pull changes to GitHub like we have been doing. So yeah, that's the plan for tonight. And then next time we'll do actually, is RPN calculator? Yeah, RPN calculator is next time. But we will we'll see that later. Excellent. So then, please let's take 10 minutes. We'll be back at 7:07. And in the meantime, if you're here in the room, I would appreciate it if we could get several volunteers, as many as 6, to participate in the operating theater. Thanks. What is? No, oh yeah, you put your name in the pom.xml of the tennis. Yeah. Yep, in the CODS repository. I'm going to tennis. Okay, well, if you volunteered, let's come to the front of the room here and bring your laptop, I guess. Assuming everybody's got one. One more spot. Want to join in? That's right. Yeah. Primary. See if you're about caffeine. Chocolate scotch. Yeah. So late at night, you can't. I'm gonna have classes. Okay. Okay, so I'll just start with let's see how far we can get. 5 minutes of just talking about the problem. So this tennis game. Where's people's thoughts about kind of tests that we should write, and maybe what kind of API, for lack of a better word, design of the class and the methods and stuff. Yeah.
So for the deuce, when somebody scores a point during deuce, they're given an advantage. So we have someone display that, and if the other person without the advantage wins, then it goes back to 40 all.
Okay, yeah, I like that.
I liked in the description here, point number 2 from the whole description. The running score of each game is described in theory of tennis. Scores from 0 to 3 points are described as low. So if we think about just defining our scores as 0 is low, 1 is 15, 2 is 30, 3 is 40, and 4 is advantage for that player, and then just sort of define the rules based off of what each player's score is.
Yeah. Okay. Yeah. Okay. Yeah, that second set of rules sort of makes it a little more algorithmic, doesn't it? Yeah. Cool. Okay. Okay, so that's some of the implementation. What would a test look like? How do we express these things, and how do we express the interaction of the game? yeah, I was thinking unit tests first though.
Yeah, I feel like the very base thing that we do is like test that we can like return and get back a score, right?
Okay. So like, that's like a method or something where you
Yeah.
say like, yeah.
Do we have any classes design or research do everything?
Nah, you just get like the empty kind of thing. That's like, yeah, the main method probably that we're coming around.
Realizing how little I know about that.
Yeah, I know, right? It's just like it's been a while.
Just like you just hit a ball, right? You get a different amount of scores.
I guess up your elbow.
You hit
I
it.
don't know. It's like,
I mean, yeah. The only time the score is affected is when the player wins a
ball.
Several.
right. This assignment
Is there any way, like, are we, I guess we're just like inputting player one score updates and they get a point. There's no like back and forth.
No, yeah, you're not gonna like play pawn or whatever. Like that. Yeah, so I think it's just, yeah, that's a good point though. It's I think it's you decide sort of have boundaries. Like, yeah, it's gonna be like, okay, player one score, player two score, right? And that's probably the interaction. Yeah, I like that. It's like, okay, you say, hey, these players score, and then I guess you ask, what's the maybe it's not the score. They win a rally, or what do we call it? Okay, so like player one wins the rally, player two wins the rally. Do that, and then say, hey, what's the score? And then say which player has which player has the score, and then maybe also did a player win or is the game over? Or something like that.
Would we maybe want to just do like a random assigner for each round, or like player one, player two, randomly assign them like four example scores to like simulate the round being run?
Oh, yeah. What do we think about that? Yeah, so
if that's if I think there's not a lot of combinations. So it just sort of
yeah, I wonder in the random situation, like how you would validate what was expected.
I think we could do it because there's only four possible scores, right?
Right.
15, 30, 40.
Right.
So we could do it and just have like a pretty simple class method, I guess it would be in Java. That's just like run round player one has like maybe in the player class like a field for like maybe like score plus equals whatever like the value is.
Okay,
Not
yeah, because we're
sure.
talking about numbers and stuff.
Yeah,
Yeah.
yeah.
Okay, yeah.
I was thinking that as the program, we are the ball, right? And then the ball goes towards, I don't know, towards player one. If player one hits it properly, or towards player two, we can implement, actually,
There we go. Yeah, right. You are right. Wii tennis. There you go. Yeah.
that's actually
The Android kind of next. It's like, cool. Okay. Gosh. Okay, we got 12 seconds left. I don't know. Is there anything more we need to discuss? Anything we need to like write down? I realize we have these great discussions, and like I can write anything on the whiteboard here and there. Yeah.
Displaying like if it's a tight score, they say all like 15 all or 30 all.
Oh, yeah.
Display it like that, or do we want just two scores?
What's the point? That's like a nice like sort of phase two type thing, right? So we can like do we get the logic for the scores, and then we can have another thing that talks about displaying the score nicely. So even like maybe like the deuce calculation could be like part of the pre-display as opposed to like you said. Yeah, because deuce I suppose is the score of the game, the score of individual.
It's a deuce whenever both players have a four, right?
Yeah.
and no player has advantage.
And it says okay, so it says a game is won by the first player to have at least 4 points. So love
Yeah,
15,
score.
30, and 40 are all points.
Yeah, well, it means they've scored. I guess it's
Okay.
like, that's not necessarily who scores 40 points first. Well, I think it's time to start. We got room for one more. Yeah. Okay, yeah. Cool. Okay, then. I'll navigate first. Who wants to drive first? And you can join the Zoom. Actually, sorry, I guess I should have said join the Zoom without audio. And yeah. Oh, Sam, you go. Okay. Or yeah, I'd go to Zoom. Oh, and I will. Oh. I think it would share. So nice. Oh, oh, I got to put it in the right place. There you go.
Oh.
Yeah, that's just weird way to do this. Okay, so sorry. Let's go to full screen. Full screen. Nice. Okay. Okay. So let's start. I'll
Who should I be listening to?
you should listen to me, but I'm going to listen to everybody else.
Right.
So, 8 minutes? No, do 8. Okay. So where should we start? I reckon we write a test first. So, like, what's the first test to write? And so then, cool. So like they both start out with 0 or something.
Yeah.
Okay. Nice. So then, so yeah, nice. Yep. So great. Okay. Well,
So is love 0?
yes. Yep. Okay. Well, so then, what are we thinking in terms of like classes and methods and stuff? What's a So like a player class, or is there a game class? What's the concept we want to model?
I think we should have a game class that holds the total score from both player 1 and player 2, then have the game class call a player class which holds the score of the player.
Okay. Okay. Cool. Well, so yeah, I like when you put that because like player class probably might not even be involved in the test. Okay. Well, then Sam, if you could create a game class, I guess. This is a game. Yeah. I don't think there needs to be any constructor parameters. It's not right now. So yeah, you create that class in IntelliJ and. Oh yeah. Actually, yeah. Rename that tenants. Yeah, that's a good point. Yeah, it's called game. Yeah, I like that. Cool. Yep. Doesn't assert anything though.
Oh.
Okay.
We can assert that it's like the object has been instantiated. It's not null.
Yeah.
Well, we can. I don't know if that's
It's not
terribly interesting though.
I mean, the thing with this test is that we're trying to assert that the player scores are 0.
Yeah,
Right?
right.
So
So-
we need to make players. We want players to just be a field and game, or we want
Well, before we go to that implementation, like, how would we express that in the test? So, like-
I think it would be like game player 1, assert that game player 1, 0, player 2, 0, right?
Yeah, I like that. I mean, so Sam, do you see how to implement that?
I mean, yeah. So you're thinking like we'll have an entire player class. Am I allowed to say my thoughts?
You are,
Okay.
yes.
I feel like-
And although you can also express your thoughts in code, and we can say,
Sure.
oh, that's a good idea, maybe that's not
So I
good.
feel like we're overcomplicating it a bit because like a player's only attribute for this
Yeah.
instance is just an int that is their score. So why don't we just use int maybe for like player 1 score and player 2 score? So like
Can we express that in a test first, though?
sure, yep. That's good.
Because I think that might
Yeah.
then, that might help us understand. So yeah, it sounds like you've got a good idea there. So like, yeah, what will you assert?
So I guess would be assert
Okay.
So like we're saying, like, oh, we instantiate a new game with no parameters or no, and we would want the player one score to be 0 if it's zero one.
I don't know. What do we think? That's good? I think the thing I would recommend, yeah, you can use that. Instead of having this be a field, let's have it be a get method. Right? That way we can encapsulate things. And that way, if we do end up having a player class, we don't need to expose it to the test. Nice. Yeah, there you go.
Just for the red hat.
Eh,
Oh, the tail, look at that. Okay. So now,
Do you know why it failed?
that method does not exist.
I would do it.
I can't remember what it is, like control and create to bring the menu up automatically.
Control Enter, I think. Well, the Control Q toggles that preview there. But yeah, if you say, and I know you're on Windows. Yeah. So it's or Alt Enter or whatever.
Private attribute here.
And does this need to be static for us to access it on test?
No.
Get,
Yeah.
get method, right?
I think
Does the get method need to be static?
we would have, if tennis is going to have our main method, then anything in tennis, the main would need to be static. This could just be a non-static accessor method.
Do we want to make the player as a class, or do we just want to keep it as an integer representation?
I don't think it needs to be a class because it doesn't really have any other attributes besides the score, right? So I think that would just be kind of like overkill.
It is, but
No, that's yeah. I mean, I'm
Oh
saying
yeah,
like,
yeah.
it's the-
I'm a big fan of keeping it simple, and so we
Yeah.
can always add one later, right? If we decide we need it.
So I'm defaulting P1 score to 0. We've got this accessor method get P1 score that will return it. And so now this should go right here. Great. Yeah. This will fail because it's red.
now for the second test, do you want to make it more of a, like, do you want to display like the scores from both players? Like, player one has colon this score, player two has colon this score. Or what do you want to do next for the next test?
Should we test from incrementing the score?
You want to test incrementing the score first?
We'd also talked about sort of like this like pretty display for the game. Do you want to do that now, or do you want to implement more of the? I don't know.
That's what I was
Yeah.
talking about. Just a second.
I think I can get to that. If I may. So, test void test to string. So, like,
Yeah, we're going with that.
or finish writing this.
Well, you're going to be the navigator next. You can tell someone else to write it. Actually, I would like you to pencil down. So delete that line so it compiles and check it in. But I think now you'll be able to drive. You'll be able to navigate the next person, the next driver, after we have a brief retrospective. So while he's committing, so mobbers, what did you think? What did you see? What did you feel? What was effective? What was not effective?
We changed the course of idea from going from having a class and then instantiating another class inside of the game class to just
And how did that make you feel? Okay.
I mean, that's the simpler way to go, right? But
What's the dynamic like working with so many people? I mean, so many people, what was it like being a mobber? Yeah, what did you like about it?
You get a lot of different ideas. It does make it feel like the workflow goes faster.
What was it like being the driver, having so many voices around you? Including the voices of your own.
I mean, it was not, there weren't more than one person talking, so I appreciate your being respectful. And for allowing me to also speak while I'm driving. Yeah. I think that was just like the one thing where it's just like, okay, do I need to be like just robotic and just wait for like the lead navigator, the person shotgun to tell me what to do, or the pulling us back from the player thing was sort of like a thing that I introduced. So yeah.
Well, I think as long as everybody's okay with it, if all the dynamic was okay, I think we always need to be mindful of the person saying on the keyboard, exerting a little too much control and not taking in the the points of view of other people. But I think in this case, I don't know, is everybody feeling okay about it?
Yeah.
Okay. Pretty good. Okay, let's start another round then. Let's see here. So Sam's the next driver. Next navigator. Who's gonna drive? Okay, do it.
It's already pushed.
Okay, cool. So yeah, share your screen and then yep.
I know where it's going. So.
Oh, okay. So you're IntelliJ.
I need both, so.
Okay, yeah, pull and then we might need to resync the Maven project. So over on, I don't see Maven. That's weird.
That would explain like getting emails that Megan CIL is failing.
Yeah, maybe. Huh. Show up at the top. Oh, interesting. It looks like you've got both directories there, so that's probably what's messing it up. So let's just open up a new IntelliJ project for you. So if you close this project out. Yeah, close project, and then open it up again. Sorry. Open up now. Oh.
It's more convenient.
Share screen again. Oh. Okay. Let's go for 8 minutes. Okay. So take it away, designated navigator.
So where I left off was with the other in the tennis test. So I figured like if we're moving on to a sort of like a printed representation of the game, we can do that through like a two-string method, right? So we just make a string out of the game that can just be love dash love or love all, or something like that.
What is the
Seems to know the most about the tennis rules, so.
Well, yeah, whenever it's just high, it's just whatever the score is, all. That's how they say it. So we say 15 all, 30 all. Just make sure I go through everything that in two strings, kind of output like current game state kind of thing.
Yeah, that was the idea. because we don't have any like methods to change what the scores are. So we could just have the two strings output like all as a very basic like not implementing any more.
And in two-string, we're going to have checks like for each player's score.
Yeah, there should be a comparison.
Ultimately, yeah.
Do we mind seeing that in screen, or do we mind it for scores?
I think having another method for comparing scores.
Yeah.
Can you just be like a getter? Just show the Boolean or comparison.
Yeah. A getter comparison function.
Just algebra method.
Yeah, do we want to test using those?
Yeah. Yeah, we do, I think just the basic like a test-driven development.
Well, it's not going to run right now because you have to override the two-string method in the game class. So
Well, I want to see it fail.
Yeah,
It's right now.
we should see it fail.
run
That's
on the
the
red hat version.
yeah.
There you go.
Oh, okay. There we go. Oh, interesting. They expected an actual power burst.
Yeah.
This is why I like, yeah, that's, assert equals is like the old J unit way of doing it. That's why I like using ham crests for it, but
Insert that.
equal to, I always get that wrong.
Okay.
Yeah. Yeah.
There's the print.
Oh, sorry.
Yeah. Now we want to
I see it fail.
see a
Oh,
failure.
yeah.
We want more failure.
Yes.
Never enough failure.
Anybody create. Beautiful. There we go.
There we go.
Good. Expected love all, but was that nonsense. Nice.
All right. So now in string we want to override our and I'm assuming we want if.
I mean, just that on its own would turn it green. Right? It's just we don't have, there's no way right now to change this folder, so
Okay.
at the very least.
There you go. Okay. Yeah. I like that. Baby steps. Right on. Yeah, green.
So, would you guys want the next step to be an implementer for one of the players?
Yeah.
Stay.
Are we implementing this or?
Yeah.
So then after we
Well, and is increment score the right term?
Yeah,
We
this
should
is the
speak
thing
in-
I'm wondering.
Speaking the
about
language of tennis.
oh,
Like-
Win rally.
player one wins the current I don't know round.
So if they win, do they go from love to 10 or they go from love to 15? So it's like, I'm suspecting a lot of people here have never watched or played tennis. Is it like each round you can get one of these scores, or is it that you start at love and then you can get the 15 and then you can get the 30 and then you can get the 40?
I think it does increment.
Okay, so it is,
Like right.
it's incremental.
Yeah, it's just
Yeah.
1.2. It's just their weird name of saying how many points that they have, and it's
Alright.
just
0.
All right.
Kind of the
15
translation here is to
Yeah.
0 love 115. So just increments up.
All right.
Yeah.
If that's it, that's how we're doing.
But to your point about is that the right name of the method? Incur P1 score, like it would be more appropriate given like the business context, so this is a tennis game, they call it like rally or something. P1 wins rally. Yeah.
We want to do separate methods for player one and player two. I guess that's probably easiest, right? Let's make all this P1 win.
It could be refactor this, let's do that, right? So,
Do we want to keep it simpler and just like under the hood say like if player score equals 0 or 1, 2, 3, 4 versus like if player score equals 15 or 30 or 40?
Yeah, I think we should translate it when we're printing it.
Yeah.
Just
Yeah.
underneath, just have 0, 1, 2, 3, 4.
I agree.
So then in our test, we want to actually get that one.
Yes.
And I'm wondering if we even need to expose the score anymore. We should just be testing against the two-stroke.
Are we testing it?
I mean, we're kind of testing implementation at this point, as opposed to interface. So,
Well,
like-
we can go back to the toString function, but right now we just want it to work where we just have the display of some sort, any sort of display happening, and then right now we're just working on the incrementer, seeing if incrementing works and decrementing works, and after that, then we can go back to the toString function and refactor what needs to be done.
okay,
Making sure the game works and then we'll fix the scoreboard.
sounds good.
Yeah.
Okay, yeah, scoreboard. Yeah, okay,
I guess I'm going to have a
No.
I think it's,
That,
I do think we need to have a decrement player score as well.
That's right.
Player scores can go down.
Yeah, only dues.
yeah,
okay. Well,
but
but that is the end of this round. So if you could please commit your code.
Yes.
Okay, and let's start the reflection, the retrospective. Okay, okay, that was the second round. How was it different from the first round? Was anything noteworthy that was different?
yeah.
Yeah.
Did everybody feel heard? Yeah, heard. I'm sorry.
What is that?
Like, did you feel heard by the group?
Oh, heard. I thought you said heard.
Oh,
Sorry.
no.
No, I felt good.
Okay.
But there was more thought process instead of this round because, after we implemented the toString, we had to think about more things that had to come into consideration with the toString. That's a big part of the game. This displaying part. Yeah.
I appreciated thinking about like the method thing and stuff, like thinking about just like as a former career like business analyst, like you want to think about how the end user is actually going to use the tool, and so thinking about it in their context, just helping sort of see it from their perspective, helping think about you understanding the rules of tennis. I'm sorry if you're like if other people also understand it well. Being able to lean on your experience also will help us with
The small experience I have.
yeah.
It's all relative.
If we know we tennis too, it's like the rules are the same there. So
Yeah, has anyone here ever actually watched tennis?
Yeah, like a long time ago though. It's like, it was like right. It's pretty comfortable, but what was it? It was like on the inside.
I like it, it's nice. I just sit here and wait for you people to tell me what to do.
That's right. Yeah, right.
I think
It's
it's
a
the
device.
ideal way to go, you don't have to think.
Well, and actually, that's a good observation.
you
That's
were using a lot more of the audio
very
than I was using
Yeah.
also, so just haven't seen the difference.
yeah. We got the AI assistant as another model, which is great.
Yep, yeah. Yeah, and IntelliJ has a lot of really nice key shortcuts too. Yeah.
Yeah,
I've been trying to hound down on so that I can write faster.
yeah, that helps. Excellent. Okay. Well, who's the next driver? Want to just go around and have it be? Okay, good. all set. Okay, another round, another 8 minutes.
Oh, who's the lead navigator?
The previous round.
Okay, I am your boss. I want you to make, next, I think we should do a test for if both players have a score.
Sorry, if I may, did we see that last test pass? I don't remember.
Yes, sorry.
Yeah, okay,
I was
alright.
kind of just doing it on autopilot.
Oh, I know, I got it.
Silly, but intelligence trying to tell us the orders. Although I don't technically correct. Hold on.
Oh, is that what the yellow underline under unanswered equals is saying?
Yeah.
That it's okay. That's smart enough to do that. Well, oh, interesting.
Expecting it to equal 1 and then.
Right, because expected is first, then actual. Oh, yeah.
So yeah, I didn't know there insert equals instead of insert that. Maybe this can be our refactoring. We should have a refactor each round too,
There you
right?
go, yeah.
Let's refactor that to be an insert that. And then you'll have to make it equal, the second argument is gonna have to, instead of being a number, it's gonna have to be equals or equal to. Kind of 136. Equal to, yeah.
Yeah.
Let's run it again, just make sure it still works, since we refactored it. Yep. And then next, I'm assuming, should we do an increased player 2 score for doing the specific method? Just knock that out real quick. I agree.
Yeah, as if it would make sense, or before testing, like, if the, for 15 all, sure, also increase their score, yeah.
Oh, for the experience, should I be like really aggressive on top of other people so we see what it's like the most and then it's like horrible to work with? I hear your idea.
100%.
That makes it convincing, though. That's all right. That's how you know it. Yeah.
Sometimes you have to go first to spend all bags. But
Yeah.
yeah.
Yeah, because we're
Well,
gonna have to
we
do
make
it.
the test first.
It's not the most exciting test, but you know.
Then later on, not now, I think we should do the decrement, but I want to go back to the string, the displaying part and see if we can, alter that with respect to what we've added to the
Yeah.
So scoredness only goes down if both players have a deuce.
And one has the advantage, then
How do they have the advantage?
so it's like 1 by 2. If you think about it.
So if both people have deuce,
Yeah, if I have deuce.
and then one person gets the advantage, they need 1 more point and they win the game. But if they don't win the moral lead, the other person gets the point, instead of having the advantage, they go back down. So now most people go back.
Lose score, they lose it.
So I thought when you got to deuce, you got to 41, right?
Now you have to get mutual like 2.
So like get deuce twice.
You gotta be the advantage twice. You gotta win twice. Right?
So when you both get to deuce is when you can actually get points to win.
Like, let's assume it starts
Deuce
at
is, okay, if you think about it, deuce is the only point where you're equivalent,
Okay.
right? So if you're at 40-40, you're at a deuce. And what you're supposed to do, if one person has the advantage, which means they won one more game, right? Like, think about it like this, okay? You win a game. Think of it like 40 versus 50.
What is the win condition when you win the game?
Get the 45.
We get 45.
You get 45.
no.
Yeah.
It's 40 and then you win a rally. So if it, and like, let's just sort of, I'm watching this code, so I'll make sure that we're good. Get either of those So we'll probably want to, when we refactor it, make it up because now it's the public.
I think Java's prefixes are also a bit different.
They do behave differently, yeah, but we would just want both to be the same. So like, if only player one is scoring, we start at 0 or above each. Then we go player one, 15, 30, 40, and then if they score again, they win.
Oh, okay. So wait. Time out here. I'm gonna blow the whistle because, like, okay, you're writing new stuff.
I'm listening.
Okay.
Kind of message.
Yeah, I kind of like this. I mean, so should we, to help clarify, should we write the test that will explain here's what the end game looks like?
Yeah. Endgame.
Well, I mean, so you want to understand the conditions in which player one wins the game. So what if we wrote a test that
They're running back and
demonstrates?
forth, they're both hitting the ball.
Yeah,
I'm
that's all
assuming
that.
they get one of these scores, love or deuce or whatever. It's
Yeah.
just like at the end of a time, or is it like
Nope,
if they hit
it's
the
based on
ball
the
and
number.
somebody else doesn't hit the ball?
Well, let's express that in a test and see if that will help clarify the. So let's have a game where player one wins. Actually, and do you want to go through deuce though, right? Because you can win without ever going through deuce, but you want to understand the conditions after which.
Because deuce is the only condition that we decrease a score.
Yeah.
So maybe we should do deuce first because have we added in our definite score yet?
No, but I think the most basic like win condition would be kind of the first game that I described, where it's just player one scores enough to win.
Let's implement that as a test so we can help point to it.
Player scores. If we want to simulate that.
I mean, you could just call it P2 4 times. Right? Yeah.
Yeah, let's do that. Yeah, it's a better interface, right? Yeah, there's no skip ahead.
Yeah. That
Yep.
method also is a bit confusing because like a win, we're also talking about winning the game. So that's a refactoring thing.
So what should I be certain that they have 4 points?
That the player 2 has 4 points and player 1 is less than 4, right? Is that the right idea? Is that if they're not equal with each other and player 1 is less than the current score of player 2, then player 2 wins?
Well, but isn't what you asserting is that player two has won the game?
Yes.
So, and this is like for me, like exposing the score. This is kind of like testing the implementation. I want to understand the more abstract level. It's like, yeah,
Yeah.
You're good. Just fix the typo.
Oh,
Yeah, I wrote player
That's good.
1, but I wrote player 2.
It's all right. It's all right. It's good learning. Okay, let's get this code checked in, and meanwhile we'll talk about what is reserved. So what happened this time?
It was more about the logic behind what the game is.
Okay.
I think that was the main concern in this track.
Refactoring, no, that's good. Would it help if, like, this is you, like, I started talking through this with you?
No, I want you to talk through it.
There you go.
So two
There you
people
go.
are standing at a court, they
Yes.
have tennis rackets, and they're hitting the ball at each other.
Yeah.
How does one person's score go up?
So if player 1 hits the ball over to player 2's side,
Okay,
it lands once and then it lands a second time without player 2 hitting it. I don't
it
think that,
has to land the second time they hit
yes,
the score?
that's a second hit.
I don't think you need to know that
I know.
deep of tennis.
If that's the question.
I think you ask.
Oh, yeah. So that's one way. The other way is if player 2 hits it over to player 1's side and it goes out of bounds.
And
Or
they-
hits the net.
Or hits them.
And
Yeah.
that counts as player two.
That counts as player 1's.
That counts as player one.
Yeah.
is
Those
player
are the two ways.
So
that
you serve
player
it to
one
me.
can score.
I hit it back to you, but it doesn't get back to you. You win because I
Okay,
screwed up. Or if I hit it, it goes like way out of bounds. You win.
but if I hit it and you miss it, I don't get a
Also,
point.
no, that's true. Yeah, you would
Well,
also win.
We just said I have to hit it without you hitting it twice to get a score.
Without
Well,
the ball hitting the ground twice.
You'll get
So second
yeah.
bounce. Yeah.
So yeah, you can only balance once. Right.
So is
So
it
what
one
we just
hit?
Yeah.
One hit,
You only hit once when it's on your side. You have to
Okay.
hit it to the other person's side.
then where's the twice?
If the ball bounces once
But that's
on
not
the
really
other
part of what we're
person's side.
simulating here, though. I
And
think
then it
that's
has to bounce a second time?
If
or
it
you get
bounces,
my
if it
point?
bounces a second time, yeah.
Okay, so if it bounces once, I
And
don't
then,
get a
they
point.
hit it, then the rally continues.
Okay, that's fine, but if it bounces twice.
Yes.
Okay.
this is awesome. Okay,
So,
good deal. Good deal.
My
Okay.
tennis balls are just something for dogs to play.
part of development and business analysis is also like, you're very likely going to be developing code at some point in your career, or doing business analysis where you don't know what the like actual thing is. So like I worked in finance department, I know nothing about money or what finance does, but I still had to write queries and how it works and stuff for them. So there is some of like these questions, like having to like understand the game at like sometimes at like a higher level just to be able to like de-abstract it. But yeah, but it's just I guess to that question of like, are we getting too deep into the weeds? If that helps you
Yeah.
understand
So-
kind of like the game. Yeah.
This scope is, you get the point or do you not get the point? It's essentially
Yeah.
just that.
Yeah.
And this
And you just keep going until somebody gets a
Yes.
point. And is the point like be a 15?
Yes, then a 30.
it increments by 15.
No, or 30.
Except for yeah.
Okay.
Okay, let's dive back into it with a new navigator and a new driver.
Okay, so I left it off with player 1 of the game. What was it? Yeah, no.
Can we start with the refactor?
Yeah, we can do refactor.
Can we change the method from P1 win to like P1 win point?
Yeah, that's probably better.
When I was looking at it, I was like, I've been one point.
Yeah, I named that method and I was looking at it being like, they're winning the game.
Is there a P2 variation we need to? Yeah, also
I think that's
You might be able to auto refactor it too. While we're in there refactoring, can we make it so that this is also prefix the P1 so that they match?
like that.
Yeah.
So I think David, you were mentioning about like exposing like get P1 score. Do we maybe want to have like a method that's just like did P1 or something that would then implement that sort of rules of just like
Okay.
the very basic like if P1 has 4 points.
Yeah, I get that.
So it's a compares. So this is like going back to like comparing sort of thing.
Yeah.
Like we should implement some sort of comparison for P1 and P2, right? And inside of that comparison, there's like if P1 has 45 points and P2 doesn't have 45 points, which means that they pass the advantage of playing loose, right? Then P1 wins, right?
Yeah.
Okay. So you want to implement
So to boil it all down, 40 is when they have 3 points. And so advantage is the 4th point. And then they finally win at the 5th point. So that could be the condition. If they have 5 points.
so deuce only occurs at 30.
Well, deuce is, so it goes love, which is 0, 15, which is 1, 30, 40, which is 3. And so
40 is 3.
Okay, so that's the deuce point.
That's the deuce point.
Yeah,
Right.
okay. And so the score would be, let's say somebody gets the 4th point, right? It'd be deuce and then advantage on whatever the player has the advantage on.
So whoever has the 5th point wins.
Yes.
Okay. So,
You can win with 4 points. 5 points.
should we?
Only 2 of 5?
Not quite. It has to be 5. Because you have to win by 2. If the other person, let's say the score was 4-3, and the person with 3 wins another point, then they go back down to 3.
Okay.
It's just reset. That's 4-4.
You have to wait to get these to like finish the game. It's like what if you
So that would
what
be-
if you get your 40 and the other person hasn't scored at all?
You just win after that.
Okay, so you
Next
can
point.
win with
You can,
4
you can win after that.
That's a really good clarification.
Yeah, I like that.
there's kind of three states. There's either nobody's won, team one has won, two has won.
So we only want those. Okay, that makes sense. Okay,
Yeah,
so
so we can't just do like a pool, unfortunately.
Yeah.
Do we want this to be like, check win state?
Check game, yeah.
Yeah.
Yeah, I don't understand. Get winner.
Yeah.
What I would call that.
Get winner.
well, we're not
Find winner? I don't know.
There may not be a winner. So
0 means nobody's won. 1 means player one's won. All right,
Oh,
like,
yeah.
we're gonna maybe. Yeah.
That makes sense.
Write a test for how. Hey, Designated Navigator. What if we wrote a test
Oh,
first?
yeah.
Better
No,
understand.
test, of course. Okay. Test-driven development, yes. So let's write a test for.
Well, actually, don't we have the player one wins game? I don't think necessarily need a new test for this.
Oh yeah, we can. So then we could implement a function and use that function in this test to see whether P1 won, basically.
Yeah, let's do that. Say G dot. What do we mean by?
It's called maybe get.
Oh, get
Get
winner.
winner,
Yeah.
get winner, yeah.
And to see if it returns one because it's player one. So
I don't really like.
Write the test before you write the code.
Yeah, let's
Right.
go in.
So go back to the test. And then change, instead of doing get P1 score equal to 4.
Oh, you can do well, or you can do both. Or you can always have multiple asserts.
yeah, let's do another.
So,
one.
Let's do assert that get winner equal to 1 because if we're returning an integer from our get winner function, let's just return 1 or 2.
Yeah.
Like,
Okay. But
I think for like, for convention, is a get method usually just like an accessor, like getter methods? Or
Yeah, usually, but it
Yeah.
doesn't have to be.
Okay.
so this is where I'm confused for implementing this. Do you want to compare whether the score of P1 is greater than P2 or if the state of it being like if P1 has 4, right? Which means it's 1 away from winning. Like you see what I'm trying to say? Like
Yeah.
are we comparing it to greater or are we comparing like the state of which it's in to win?
So there's technically 5 states that we can be in. Nobody's won. Player 1 wins on the deuce. Player 2 wins on the deuce. Player 1 wins normally without the deuce happening. Player 2 wins normally without the deuce happening.
Do we need to consider the deuces or do we just simplify that down to
I think we could just have conditionals first and check without the deuce because the deuce will happen after they pass those states. So
yeah, we're just checking what their scores are. So
Yeah.
I think the first thing we could do is check if either of them have a score of 5. They have 5.
yeah, so
One,
if
right?
player 1 has a score of 4 and then player 2 is less than, it needs to be by 2. So that's less than 2 or less than.
What do we need to make the test pass?
Yeah, exactly.
Yeah,
Let's
sure.
keep it as
Okay.
low, which right now our test is player 1 has 4 and
Yeah.
they should.
So yeah, so the conditional should have player 1 score equal to 4.
Oh yeah.
I think conditional.
okay. And then we want to return
It's a condition of the state, the true or false. Instead of player
If
1
P1 score is equal to 4.
instead of that, just have P1 score or equal to 4.
oh, okay.
Our current testing does not have a way for players to.
Exactly.
Yeah.
Return 1.
And then return.
And then over here for the outer function, this is return statement. So if I just return
Let's return 0.
0 otherwise.
Yeah.
Just
Or you could throw an unscored operation exception because we should never get that. So that's what we're doing.
Could, because if no players won.
Sorry, what?
If no players won that.
Do we have a test that would show this?
I guess
Right.
so.
I would say bulletproof it
I understand.
so that you won't be anywhere. Nice. Okay. It's getting intense, even though
Yeah, was that too much?
No, it's not much. It's just getting used to it. Getting used to it.
yeah. What was your experience like? Yeah.
Like trying to dab other people and then trying to like also be like a mouthpiece.
Yeah. There's different a lot of voices and stuff to it. Yeah.
It's pair programming, just kind of talk to each other.
Yep. What was it like for what was it like being the actually what was it like for the other modelers?
Kind of getting more chaotic.
Oh yeah, yeah.
As it gets more complicated.
Yeah.
And I feel like we are getting closer and also further from understanding how to play the game of tennis.
Yeah.
Yeah, right, yeah.
Do you feel like it's getting more like, because it, or most of it is like more chaotic, because we're more like complicated in the code, or because we're now more familiar as a group?
Probably both. Yeah. My one disappointment though is I wish there were more navigator angry rants.
Okay.
Feel proud of
Sorry, I'll try to be more aggressive. I looked it up, by the way, if mob programming has ever gotten violent. I couldn't find it.
No, yeah, I know. But we're the mob, right? You know, yeah.
If you're
It's
gonna call
not.
it
It's not. It's not
mob,
hooligan programming. It's not like.
For me,
Yeah.
it was kind of harder to like be the driver because like I was trying to visualize the thoughts of the navigator, and my thoughts were also intersecting that, and it's like yeah, it was hard.
Yeah, it's a challenge to sort of put your like, oh yeah, I want to implement like what you kept doing, where it's like you would start implementing. It's like, no, we all want to write tests
Yeah,
first.
bring the test
We all want to write tests first. Yeah.
right?
Cool. Okay. Let's see here. How are we doing on time? It is 8:04. We got time for one more round. That'll be good because that means everybody will drive right here. Yep. Yeah. Nice. Okay. One more round.
Everybody at home having a good time?
I'm a,
All right.
okay.
So my fifth career was talking like a baby.
All right. Who's navigating?
So since we just implemented the get winner function in a very most basic format, you want to test if the player one wins game test still works. Okay. So what do you think, Mark? What's
That's
next?
a question. Am I allowed to, as a driver,
Yeah.
should we start with some refactoring?
Oh, yeah.
Like,
Yeah.
Is like this is like one win condition. Should we make this test like player one wins game without deuce or something?
Oh yeah, yeah. I like that. Yeah.
Player one's mistake.
Yeah.
Player two is a loser. Player two is a single point.
To roll. Yeah. All right. Yeah.
And we're talking about 5 states.
Yeah.
Right? So do you think we should go back to the get winner function and modify and test each state, or do you think what is that?
So we should first have like what we did with condition if statements, just name player one or two, that's 4 points, and then they have less than two or less than equal to, yeah, less than or equal to, then they whatever the player returns. Then below that have the 5-point option, which is the deuce. So okay.
I'll give a warning really quick. I do think my laptop will probably die in session.
There's an extension for all of it. I think the next easiest state would be player two.
Yeah.
So that maybe should be our next
So
step.
let's start with that. Okay.
So
let's have player two.
copy another test rank,
Yeah.
then do player 2 wins game, then player 1 with 0 points.
Well, that.
Yeah.
And then have it be on the assertive get winner, have it be equal to.
Yeah.
So we want to consider that the winner
No player has one.
No player has one.
Yeah.
Okay.
Your turn's one, player one's one, two, player. Nothing.
Yeah. Is it on? Sure. What's your fails? Let's fix it.
It might, yeah, I don't know.
Weird, but yet that's so surprising. Can you not just turn the light switch on?
No, it's not lit up.
I can sit somewhere else.
Really?
It's probably
Be one of those that was over there.
Now we're debugging from here. Yeah, physically debugging. It sets it up for, I think it's set.
So I think the next thing, yeah, is checking if he's scored.
Right on. Oh, you don't know what it is now. So,
That's
okay.
perfect.
And it has a sticker right next to it. You have the power. No, you do not have the power. There's something on you. The power has this. That has. Okay. With it?
Beware of kangaroos.
Kangaroos.
Yeah.
Nice. So,
That might.
okay, please. What's the next state that we want to consider?
Well, we.
Wait,
our
did that
test
pass?
fails, right?
Yeah, pass.
Are you sure?
Yes.
Oh, because you
Yes,
implemented
what
it?
we
Yeah,
wrote.
that's it, okay.
Yeah.
Alright. There we go, nice.
Next.
Equivalency.
I think we should
nobody wins?
do,
Yeah,
like,
okay.
snacks.
So you want to make sure that none of them are.
I think-
equal in this next scenario.
Yeah, so nobody's won.
Yeah. So
in
if
the next season.
yeah. Four is not equal to four, or that
Fine.
works too. So then now you can remove that exception. Yeah. Okay. And then you have to.
Oh, did we put a test? Did we make a test before?
Like, what
we-
test do you pass?
Yeah, what are we testing for?
Testing
Okay,
that.
Nobody's won yet.
so we should
Yeah.
change get winner to check winner.
So then we could refactor it to saying check winner instead.
If we're gonna have a case in there where nobody's won, check winner will no longer be appropriate.
Oh, yeah.
Refactor button, and go down to refactor.
I think you just do like rename.
Yep, there you go. Okay. And now you go back to the tests, and then you know you can name it as no winner yet. Perfect. Yeah. Yeah, you can make it segregation class and just do the last assert calculations.
Yeah, the new one that's for check winner.
We already have that test, don't we?
Well,
Remember,
We're
check
asserting-
winner.
we're
Yeah.
asserting that check scores are 0, which means that no winner. I mean, there are other cases where there isn't a winner, but yeah, this is just the most simplest case of checking if there's no winner.
Okay, I think you were saying we could have leveraged that previous test.
Or
case.
now I can delete our test, we don't need it. Or we don't need it, sorry, it's okay.
Yeah.
It's okay.
That's You're in the mob, so you should be here.
Oh, so now, so this is
perfect. Oh,
Yeah.
we should add this returns table.
exactly.
No way.
There we go. Okay. And back to talking about the game. So when you're at a deuce, right, which is a 4v4, no, 3v3, a 3v3, okay. If 4 is considered the advantage, right, and 5 would be the winning state. Okay. But and if you aren't at a deuce, but you have reached 4, that would indicate that you won.
Well, so when you reach 4, but the other player scores 2 or less.
Yeah, 2 or less.
Then
Okay, that makes sense. Okay.
But you could also write S for that.
Yeah, because add another test case for if D2 score is less than or equal to 2, and D1 score is greater than or equal to 4.
I think it's worse than they're called 15, 30, 40, even if they all have names like joy, acceptance. Like that 40 is that you won 3 points. It's harder to understand than if you call winning 3 points like happiness.
So, in this case, to make it fail, we want a deuce situation. So player 2 has 3, player 1 has 4, and a check number 0. Given those scores, then the winner stay with 0.
A deuce is that both people have 40, and if they both have scores of 3.
Yeah, well, that I guess would be the simplest test is both players have 3. Or 3 to get 4.
And then how do you get the advantage in?
One player scores 1.
You just play deuce, and then whoever wins gets basically a 4 points. It is like having 4 points.
Yeah.
Okay.
Okay, well, unfortunately, that's time.
I
Cool.
don't feel
Okay.
any more inspired to watch tennis. If anything,
Yeah.
I have a grudge against tennis.
I don't know. Well, but it's people wearing white, and they're like really good shape. So
That's what baseball's for.
yeah, but
I mean,
anyway.
yeah.
Awesome. Okay. Well, check in the code that we got, and so okay. Well, here we are at the end. What did you think? What's the?
I think at this round, everything else would have been easier because we then realized, or he explained to me all the states as a navigator. There were only like 5 states to consider, right? D2. Well, should I explain all the states or?
No.
No, okay. I understood all the states, and
What's the bigger lesson though?
the bigger lesson was, the more deeper we go through the rounds, there's a certain point where everything becomes easy.
Gotcha. Okay. Learning.
I think in cases that if there are people, maybe it would have helped us at some point to take a pause from the Pomodoros and go back to the specifications and just make sure that everybody's clear on the rules of the states, because they are kind of all specified out in that the code,
Oh, on the page.
yeah, the coding dojo
Okay.
page.
Yeah.
Oh, yeah.
Yeah, so that inferring each of the 5 states.
But the interesting thing is that that's like the implementation. I think what we struggle to understand is like what it is that we're trying to model, and therefore how we test it. Which I think is for me, I think that was like the most interesting thing, right? Where it was acknowledging that this is a domain that we're not familiar with. So how do you explore a domain that you're not familiar with, and what is the dynamic like when it's in the model? Excellent. Hey, and touch on the peanut gallery. So those of you who are maybe watching, any observations, anything you're going to take into Wednesday night as you do this on your own? Teamwork. There you go. Sorry, do it in your own. Well, they'll be doing it. Yeah, they'll be doing it with a mom, I guess.
And so those.
No, you're going to be so experienced. You're going to be like.
We'll be the mob leaders.
Yeah.
I'll try to think of ways to make that mobbing 5 minutes.
Okay. Yeah. It's like you're all like Mad Max up in flamethrower or something like that.
They're never going to flail.
Yeah.
Flash mob programming. We all just show up at the mall.
Yeah, that would be good actually.
No. Okay. Awesome. Okay. Well, hey, this is what we'll be doing on Wednesday. Please join us here. I'll bring the HDMI cables and maybe some cool snacks too. Thanks for sticking with us, everybody remotely. We'll see you later.
Oh, no, I brought them.